In this course, you're going to learn everything you need to get started with Python. Just be aware that I've designed this course for beginners, so if you have some programming experience, check out my other Python course for developers. You can see the link on the top right corner of this video. So, Python is the world's fastest growing and most popular programming language, not just amongst software developers, but also amongst mathematicians, data analysts, scientists, accountants, network engineers, and even kids. In fact, it's the ideal programming language to learn first. But what makes Python so special? Here are 6 reasons. With Python, you can solve complex problems in less time with fewer lines of code than many other languages. That's why huge companies like Google, Spotify, Dropbox, and Facebook have embraced this beautiful and powerful language. Here's an example. Let's say we want to extract the first 3 characters of the text "Hello World." This is the code we would have to write in C#. This is how we would do this in JavaScript. And here's how we would do it in Python. See how clean and simple the language is? And that's just the beginning. Python is a multi-purpose language, and you can use it for a wide range of jobs such as data analysis, AI and machine learning, writing automation scripts, building web, mobile, and desktop applications, as well as software testing or even hacking. So if you want a high-paying, long-lasting career in any of these areas, especially AI and machine learning, Python is the language to put those opportunities at your fingertips. In fact, according to Indeed.com, the average salary of a Python developer in the US was over $115,000 in March 2018. And here are 4 more reasons that make Python the most desirable language. Python is a high-level language, so you don't have to worry about complex tasks such as memory management as you do in C++. It's cross-platform, which means you can build and run Python apps on Windows, Mac, and Linux. It has a huge community, so whenever you get stuck, there is someone out there to help. And it has a large ecosystem of libraries, frameworks, and tools. Whatever you want to do, it is likely that someone else has done it before, because Python has been around for over 20 years. There are 2 versions of Python out there. Python 2, which is the legacy version of Python and is going to be supported until year 2020. And Python 3, which is Python for the future. In this course, you're going to learn Python. Alright, now we're ready to download and install Python. The first thing I want you to do is to open up your browser and head over to python.org. On this page, under the downloads, you can see the latest version of Python. Currently, the latest version is 3.7. Chances are in the future, when you're watching this video, there is a newer version available. Don't worry, all the materials in this course will continue to apply with the future versions of Python. So go ahead and download Python and then run it. If you're on Windows, you're going to see this checkbox here, add Python to path. This is very important. Make sure to tick it, otherwise you're not going to be able to follow the course. So now go ahead and install it. Now let's verify that we have installed Python properly. If you're on Windows, here in this search bar, type CMD, which is short for command prompt. Now here in command prompt, type Python. You can see we have successfully installed Python version 3.7. Now to exit, press Ctrl Z and then enter. Done. If you're on Mac, press Command and space. This opens up the Spotlight search. So here type terminal. Terminal on Mac is like command prompt on Windows. Now Mac and Linux by default come with an older version of Python, that is version 2. So if you type Python, you can see Python 2 here. That's not what we want. So press Ctrl D to exit and then run Python 3. And this verifies that we have successfully installed Python 3.7. So this environment you see here is what we call Python interpreter, which is basically a program that executes Python code. We can type our Python code in a file and give it to this interpreter, or we can type our code directly here in this interactive shell. So here we can write an expression like 2 plus 2. In programming, an expression is a piece of code that produces a value. So here, when we add 2 plus 2, we get a value. That is why we refer to this piece of code as an expression. So enter, we get 4. Let's try a different kind of expression. Let's see if 2 is greater than 1. We get true, which is an example of a Boolean value. You're going to learn about these Boolean values in the next section. Now, what if we type 2 is greater than 5? Enter, we get false. So in programming, we have true and false, which are similar to yes and no in English. Now, what if we type 2 is greater than, but we don't add a second value here? Just press enter. We get a syntax error. In programming, syntax means grammar. So just like we have the concept of grammar in the languages that we speak, we have the exact same concept in programming. If we write a sentence that is not grammatically correct, chances are some people may not understand that sentence. So in this example, we have this expression which is incomplete. It doesn't have the right grammar or syntax. That is why Python interpreter is complaining by returning an error. So this interactive shell is a great way to quickly experiment with a bit of Python code. But that's not how we build real-world applications. To do that, we need a code editor. And that's what I'm going to show you in the next lecture. When it comes to typing Python code, you have two options. You can use a code editor or an IDE, which is short for Integrated Development Environment. An IDE is basically a code editor with some fancy features like auto-completion, which means as you type code, this feature helps you complete your code. So you don't have to type every character by hand. It's a productivity boosting feature. It also gives you additional features like debugging, which means finding and fixing bugs in your programs, testing, and so on. For both code editors and IDEs, there's so many options out there. The most popular code editors are VS Code, Atom, and Sublime. You can use the code editor that you prefer. In terms of the IDEs, again, there are so many options out there. The most popular one is PyCharm. In this course, I'm going to use VS Code or Visual Studio Code because that's my favorite code editor. Later in the course, I will show you how to install a plugin or an extension that will convert VS Code to a powerful IDE. So before going any further, head over to code.visualstudio.com and download the latest version of VS Code. Now with VS Code open, on the top, from the File menu, go to Open, and somewhere on your disk, create a new folder. Let's call this folder Hello World. And then open it. Beautiful. Now click this icon on the top. This opens up the Explorer panel. In this panel, you can see all the files and folders in your project. So let's add a new file and call that app.py. So all our Python files should have the py extension. Press enter. Now let's close this and type a bit of Python code. In this lecture, we're going to use one of the built-in functions in Python called print. So in Python, we have a lot of built-in functions for performing various kinds of tasks. For example, as a metaphor, think of the remote control of your TV. On this remote control, you have a bunch of functions like turn on, turn off, change the channel, change the volume, and so on. These are the built-in functions in your TV. We have the same concept in Python and many other programming languages. So one of these built-in functions that comes with Python is print. And we can use this to print something on the screen. Now, whenever you want to use a function, you should open and close parentheses. In programming, we say we're calling the print function. Calling a function means executing it. Now let's display the hello world message on the screen. Whenever you want to work with text, you should put your text in between quotes, either double quotes or single quotes. Now I'm going to go with double quotes and add hello world, and then put a happy Persian cat here. Beautiful. Save the changes with Command and S on Mac or Control and S on Windows. Now to execute this code, we need to go back to Command Prompt on Windows or Terminal on Mac. But the good news is that we don't have to switch programs. Here in VS Code, we have an integrated terminal. So press Control and backtick. That is the key before number 1 on your keyboard. That is just below the escape button. So this is our integrated terminal. Now if you're on Windows, type Python. If you're on Mac or Linux, type Python 3. And next to that, add the name of our file. That is app.py. And here's our hello world message in the terminal. Beautiful. Now let's take this to the next level and make it a little bit more interesting. Let's close this terminal window by pressing Control and backtick and add a second line of code. So one more time, print. This time, let's add quotes with a star in between them. Now let's say we want to repeat this star 10 times. So here we can multiply this by 10, save the changes, open up the terminal, and run our program. And you can see this star is repeated 10 times. So as you see, the instructions in our program are executed from top to bottom in order. In the next lecture, I'm going to show you how to convert this VS Code to a powerful IDE for building Python applications. Lecture, I'm going to show you how to convert VS Code to a powerful IDE by using an extension called Python. With this extension or plugin, we get a number of features such as linting, which basically means analyzing our code for potential errors. We also get debugging, which involves finding and fixing errors. We'll look at this later in the course. We also get auto-completion, which basically helps us write code faster, so we don't have to type every character. We get code formatting, which is all about making our code clean and readable, just like how we format our articles, newspapers, books to make them clean and readable. We get unit testing, which involves writing a bunch of tests for our code. We can run these tests in an automated fashion to make sure our code is behaving correctly. And finally, we get code snippets, which are reusable code blocks that we can quickly generate, so we don't have to type them all by hand. Now, don't worry about memorizing any of these. As we go through the course, you're going to learn about these features. Now, here in VS Code, on the left side, click this icon. This opens the extensions tab. So these are the extensions that we can install in VS Code to bring in additional functionality. Here under the recommended tab, you can see the Python extension. If you don't see this, simply type Python here on the top. And here's the extension. So go ahead and install this. And then you will have to reload VS Code. Now here on the bottom right corner, you can see this message, linter pylint is not installed. So as I told you before, linting is about finding potential errors in our code. Linter is a program or a tool that analyzes our code and finds these potential problems. Now for Python, there are several linters out there. Pylint is one of the most popular ones that this Python extension uses by default. So we need to go ahead and install Pylint as well. Now to do this, first we need to change our Python environment. So if you look here on the bottom left corner, you can see the current Python that is used in VS Code. That is Python 2.6.9 on my machine. Chances are you see a different version here. So click here, and in this list, make sure to select Python 3.7. So this changes our Python environment to Python 3.7, and then we can install Pylint by clicking this button. Okay, Pylint is installed. Beautiful. In the next lecture, I will show you how linting works. In this lecture, I'm going to show you linting in action. So let's start by writing some invalid code like this. Print, space, with no parentheses, and then hello world. Earlier, I told you that print is a built-in function, and whenever you want to use or call a function, you should always use parentheses. Now, to be more precise, this is actually valid Python 2 code, but because we're using Python 3 here, this is invalid code from Python 3's point of view. So now when I save the changes, you can see this red underline here. Let's hover our mouse over this underline. You can see this tooltip. It's coming from Pylint, and here's the error message, missing parentheses in call to print. Did you mean print with parentheses? So this is the benefit of linting. As you're writing code, you can see potential problems in your code. You don't have to wait to run your program to see these errors. So now, if we put parentheses here and save the changes, you can see that red underline is gone. Let's look at another error. Let's type 2 plus and then save the changes. Earlier, we ran this code in Python interpreter's interactive shell. There, we got a syntax or grammar error. So if you hover your mouse here one more time, you can see pylint is telling us that this is invalid syntax or invalid grammar. It's like an incomplete sentence. So this is linting in action. Now let me show you a couple useful shortcuts here. On the top, look at the view menu. Here we have this problems menu. Look at the shortcut. On Mac, it's Shift, Command, and M. On Windows, it's probably Shift, Control, M. So as you're working with VS Code, try to memorize these shortcuts because they really help you write code faster. Now let's take a look at this problems panel. So this problems panel lists all the issues in your code in one place. So if you have an application with multiple files, this is really useful because some of those files may not currently be open. So this linter, pylint, will analyze all your files, and if it finds any issues, it will list them here in the problems panel. Now you can also put this on the right side of the screen. So let's put it here. So as you write code, these problems will appear here. Now let's fix this issue. So I'm going to add 3 here, save the changes, and you can see the problem disappeared. And one last thing before we finish this lecture. Once again on the top, let's go to the view menu. The first item is command palette. This is a very important feature in VS Code. Once again, look at the shortcut that is Shift, Command, and P on Mac or Shift, Control, P on Windows. With this command palette, you can execute various commands in VS Code. If you type lint here, you can see all commands related to linting. As you can see, all these commands are prefixed with Python because these commands come with the Python extension that we installed earlier. So these are additional features available to us in VS Code. The first command here is select linter. In this list, you can see various linters available for Pylint. So as you're reading tutorials or talking to other people, you will hear about linters such as Flake 8, MyPy, Pep8, and so on. Different developers prefer different linters. I personally prefer Pylint. That is the most popular one, and that is the default linter set in the Python extension of VS Code. If you're adventurous, you can try using other linters on your own. The difference between these linters is in how they find and report errors. Some error messages are more meaningful or more friendly. The others are more ambiguous. So that's all about linting. In the next lecture, we'll talk about formatting code. In Python community, we have a bunch of documents called Python Enhancement Proposals or PEPs. Here on Google, if you search for Python PEPs, you can see the list of all these PEPs under python.org/dev/PEPs. Let's have a quick look here. So here are the PEPs. You can see each PEP has a number and a title. The one that is very popular amongst Python developers is Pep8, which is a style guide for Python code. A style guide is basically a document that defines a bunch of rules for formatting and styling our code. If you follow these conventions, the code that you write will end up being consistent with other people's code. Now, if you have time, you can go ahead and read this Pep8 documentation. But if not, don't worry, because throughout this course, I'm going to explain the key things in Pep8. In this lecture, I'm going to show you a tool that helps you automatically format your code according to Pep8. So back in VS Code, let's write some Python code. X equals 1. Here I'm declaring a variable and setting it to 1. If you're not familiar with variables, don't worry. In the next section, you're going to learn about them. So according to Pep8, this code is considered ugly because by convention, we should add a space around this equal sign or the assignment operator. Now, since you're starting out with Python, you probably don't know these rules. So let me show you a tool that helps you automatically format your code. Let's revert this back to its original state. Now we need to go back to the command palette, remember? So it's right here under View, and the shortcut is Shift, Command, and P. Here, if you search for format, you can see this command, format document. The first time you execute this command, you're going to see this message here. Formatter AutoPep8 is not installed. So there are a bunch of tools for formatting Python code. The most popular one is AutoPep8. And this is the tool that this Python extension we installed uses to format our code. So let's go ahead and install this. Good. Now, one more time, let's open up the command palette and execute format document. See, this tool automatically formats our code. Beautiful. Let's take a look at another example. I'm going to declare another variable, y, and set it to 2, and a variable with a long name, like unit underline price, and we set this to 3. Now, some developers have this habit of formatting their variable declarations like this. So they put all these equal signs in the same column. According to PEP8, this is considered ugly. So once again, let's format our code. That is better. Beautiful. Now let me show you a trick. Opening up this command palette and searching for format document every time is a little bit time consuming. So I'm going to show you how to have your file automatically formatted as soon as you save the changes. On the top, let's go to the code menu, preferences, and settings. Here in the search box, search for format on save. So we have this option, editor, format on save. Take this. Now back to app.py. I'm going to change the formatting of these lines, make them really ugly. Now, as soon as I save the changes, you can see my code is reformatted. Beautiful. So you have learned that in order to run this Python program, we'll have to open up the terminal window and run Python on Windows or Python 3 on Mac, and then app.py. This is a little bit tedious. So let me show you a shortcut. Once again, let's go to the extensions panel. Here, search for code runner. There are multiple code runners out there. The one that I'm talking about is this one with the yellow icon. So go ahead and install this and then reload VS Code. Now, instead of opening up the terminal and manually typing Python app.py, all you have to do is to press Ctrl, Alt, and N. You can see the output here. Beautiful. Just be aware that if you make any changes, you will have to save the changes before using this shortcut. Otherwise, you're going to see the old result. Now, there is a tiny problem here. So you can see this is the command that is executed to run this Python program. So by default, this command is using python-u, and here is the name of our file. If you're on Windows, that's perfectly fine. But if you're on Mac, you know that Python refers to Python 2. Here we want to change this to Python 3. This is very easy. Once again, on the top, under the code menu, let's go to Preferences, Settings. And then here, under this ... go to Open Settings.json. Now here in the search bar, type code-runner.executor map. So these are the default settings used by this code runner extension. You can see this extension supports executing code in a lot of languages like JavaScript, Java, and so on. Now, if you scroll down, here you can see Python, and in front of that, you can see the command that is used to execute Python code. We need to change this. However, we cannot change the default settings. We should change the user settings. So on the right side, after the last setting, type a comma, and then in quotes, type code-runner.executor map, and then press enter. This will automatically copy all the settings on the left side to the right side. Now we can easily change one of these. So here's Python. Let's change the command to Python 3. You only have to do this if you're on Mac. And by the way, sorry if I have mentioned Windows and Mac a few times throughout this course. That's pretty much it. We're not going to differentiate between Windows and Mac in the future. So save the changes and we're done. Closely related, Python language and a particular implementation. Python as a language is just a specification that defines a set of rules and grammar for writing Python code. A Python implementation is basically a program that understands those rules and can execute Python code. Earlier in the course, we downloaded Python from python.org. This is the default implementation of Python called CPython. It's a program written in C, that's why it's called CPython. So here in terminal, when we run Python, we get this CPython. This is the default implementation of Python. There are a few other implementations out there, such as JSON, written in Java, IronPython, written in C#, and PyPy, written in a subset of Python itself. As new features are added to the Python language, they are first supported by CPython because that's the default implementation, and then they will gradually come to the other implementations. In theory, if we give some Python code to any of these implementations, we should get the same result. But in practice, that's not always the case. Certain features may be available in one implementation but not another, or they may just behave a little bit differently in a particular implementation. Now you might ask, but what is the point of this? Why do we have several implementations of Python? Wouldn't CPython be enough? Well, it's for the same reason that we have multiple operating systems, or multiple browsers, or multiple programming languages. After all these years, we programmers haven't agreed on a single programming language, and that's the same story with Python implementations. However, there is one technical reason behind these implementations that you should be aware of. Since JSON is implemented in Java, it allows you to reuse some existing Java code in a Python program. So if you're a Java developer and you want to import some Java code into a Python program, you should use JSON instead of CPython. Similarly, IronPython is written in C#, so if you're a C# developer and want to bring some C# code into a Python program, you will have to use IronPython. Next, we'll look at how exactly CPython executes Python code. The languages we use, like C, C#, Java, Python, these are all simple text-based languages that we humans understand. Computers don't understand them. They only understand machine code. So if we have some code written in C, we should convert it to machine code. And that's the job of a C compiler. So a C compiler is a program that knows how to convert or compile C code into machine code. However, this machine code is specific to the type of CPU of a computer. So if we compile a C program on a Windows machine, we can't execute it on a Mac. Because Windows and Mac have different machine code, just like how people from different countries speak different languages. Java came to solve this problem. Java compiler doesn't compile Java code into machine code. Instead, it compiles it into a portable language called Java bytecode, which is not specific to a hardware platform like Windows or Mac. Now, we still need to convert Java bytecode to machine code. So Java also comes with a program called Java Virtual Machine, or JVM, for doing this. When we run a Java program, JVM kicks in, it loads our Java bytecode, and then at runtime, it will convert each instruction to machine code. With this model, we can run Java bytecode on any platforms that have a JVM. We have JVM implementations for Windows, Mac, and so on. So the JVM implementation on Windows knows how to convert Java bytecode into machine code that a Windows machine can understand. C# and Python have also taken the same route, so they are platform independent. When we run a Python program using CPython, first it will compile our Python code into Python bytecode, then it will pass that bytecode to Python virtual machine, which will in turn convert it into machine code and execute it. This is how CPython works. In the last lecture, we talked about various Python implementations. I told you that if you want to reuse some Java code in a Python program, you should use JSON. Now let's see how JSON makes this possible. When you use JSON to run a Python program, instead of compiling your Python code into Python bytecode, it will compile it to Java bytecode. So we can take this Java bytecode and run it using Java virtual machine. And that's why you can import some Java code into a Python program when using JSON, because the end result is Java bytecode, which will eventually be executed by Java virtual machine. So I've got a few questions for you because I want to see if you have been really paying attention to this video or not. You better have. So here's the first question. For each question, I want you to pause the video, think about the answer for a few seconds. When you're ready, continue watching. So here's the first question. What is an expression? An expression is a piece of code that produces a value. Here's an example of an expression. What do you think is the value of this expression? Well, here we have this string. We're multiplying this by 3. So the result will be a string of 3 asterisks, like this. Here's another question. What is a syntax error? A syntax error is a kind of error that is due to bad syntax or bad grammar in the code. And finally, the last question. What does a linter do? A linter is a tool that checks our code for potential errors, mostly in the category of syntactical errors. So if you have grammatical issues in our code, the linter will tell us before running our